Well, good morning, Math 150 beginning algebra students. It's morning for me. When you're watching this, it could be middle of the night, 2 in the morning, afternoon after you've had lunch. So whatever time of day it is, hopefully it's starting off well or it's been going good. For me, we're going to take a look at the next section in chapter 8, 8.5. And this section's titled solving radical equations, solving. And here's the difference between solving and simplifying. Solving, you're going to have an equation, which means you got an equal sign. Simplifying, no equation, no equal sign. That's it. So the first, I guess, 4 sections that you had in chapter 8, instructions did not say solve. It said either simplify, might have been multiply or divide, add or subtract. That's just another way of saying simplify. And then simplify at the end, of course. But in chapter 8.5, you're going to end up solving equations, and your goal is to get the variable by itself. And I'm going to show you how to do that. And I recommend that you get it on the left-hand side. So in solving equations that we're going to do today, your target is to try to find an answer that would work in the original. So here's what you need to do. When you get that answer, you think it's an answer, you get the answer, you plug it into the original equation. Now the reason why you do that is to see if your answer in any equation works in the original, because that's what you go back to. Plug it into the original, and if it checks out, great, box your answer, move on. On occasions, particularly when we deal with radical equations like we are, mysterious reason, sometimes we get an answer that doesn't check out. And if you plug it in and it's false, it doesn't check out, then the answer that you thought was right, you'd say doesn't work. And then your statement at the end would say something like, no solution. And on 1 or 2 problems coming up, I think there's an opportunity to get 2 possible answers. You got to check them both. And if they both work, then great, they both work. But sometimes one works and one doesn't, and you throw away the one that doesn't work. The ones that don't work, sometimes we would call those in mathematics extraneous, big fancy word, extraneous solutions. Like they look like they work, but they don't. Extraneous. Anyway, all you need to do is find the ones that work. Okay, here we go. One moment. Okay, I'll be right back. Okay, here we go. So 8.5. As I said, you're always going to check your answers. Always. Okay, so here's the process. See the radical right here? The process is to get the radical on one side of the equation. I suggest the left-hand side. And then you square both sides. Okay, so that means all by itself. Get the 3 away. So add 3 to both sides. Simplify, of course. That's 7. And then square both sides. So square, square. The interesting thing, the nice thing about it is when you square a square root, it's like the reverse operations, they will eliminate each other. More about that next semester in a different class. More about that in another class. Just when you square a square root, all you're left is the radicand every time. 49. Add 2, x equals 51. Maybe it's the right answer. Maybe. Hopefully I've checked my answer over here. Oh yeah, I did. Check the answer. That means I plug the 51 into the original. And then work it out. 51 subtract 2. And that's 49. Square root of 49 is 7. Yeah, check, check. That worked. So that means x equals 51 is the answer, and that's what you'd look for. Say it's a multiple choice test, you'll look for 51. Okay, let's try a couple of these like it. The instructions will say to get the radical all by itself. The 2 is in the way. So you want to get rid of the 2. The 2 is in the way. So divide both sides by 2. And of course, you've got a radical x subtract 5, simplified to 2 over here. And now you take both sides, if you can see the green here, and square both sides, leaving me x subtract 5 equals 4. And then I think you can do this in your head, add 5 to both sides. You have potentially 9 is the right answer. So here I'm going to do a check. Here's the original. Replace x with 9. Remember, replace x with 9 and see if it works. 9 minus 5 is 4. 2 times root 4 is 2. Check. What that indicates to you, then, this is your answer. Okay, next problem. There's only one radical. See right here, the instructions is here. If there's exactly one radical, not 2, not 3, one radical. Yeah, one radical. Okay, get it by itself. That means I have the 5 and the 3 to handle. And you pick one of them. My suggestion is pick the add 5, because really what you're going to do is subtract 5 from both sides. I suggest that you subtract 5 from both sides first. And then now divide both sides by 3. So then you'd have square root of x equals -1. And then square both sides. That means I'll take square root of x, square it, -1, square it, leaving you x here. Now -1 squared is 1, and you better check. Here's your check. So write down the original. Replace x with 1. So 3 square root, replace x with 1. Square root of 1 is 1. That leaves me 3 times 1 plus 5. 3 times 1, of course, is 3 plus 5. Well, that's ridiculous. That doesn't work. That's not true. So that didn't work. And your statement? No solution. No solution. All right, flip the page. Now I got some problems. These are actually one of the easier ones, to tell you the truth. When you got exactly 2 radicals with nothing else around it. See, there's nothing on the outside of either one of the radicals. You want to make sure that they're on opposite sides of the equal sign first, which I think all the ones you're going to get are, as well as on the multiple choice portion. If it's exactly two radicals, they will be separate. So then you just square both sides, like I've done right here. Square both sides, rewrite the radicands, solve for x by bringing 2x to the other side by subtracting it. 2x equals 6. 2 times 3, yep, 2 times 3 is 6. So now you check it. You plug it back into the original. Remember, this is the original. Remember the original up here? Here's the original. Plug it back in, see if it's true. Yep. So that means this is your answer. If it's true at the end of the check, that's your answer. Okay, let's do a couple of these. Actually, that's the one I wanted you to do. And then a third type. Now this is a little bit more difficult. Third type, a little bit more difficult. You got radical 1. See, like one radical, and you got 2 extra terms, and one of them's a variable. 2 extra terms, 1 is a variable. So what you want to do is get the radical by itself again, like I've talked about, to one side of the equal sign, which I did. And then what you want to do is, looks like it's a binomial, so you square both sides, Okay, the left-hand side's the easy part because it's just whatever the radicand was. The right-hand side, you have to be careful. And that's what I'm saying. The binomial squared need to be written down twice so you don't make that careless mistake. Write it down twice and then FOIL and then combine like terms. So think about it. If you got inner and outer, that's 5 and 5 is 10. 10x. And now what you're going to have to do is solve. This one's a little more challenging because I've got this x squared part. So the idea is when you've got an x squared, when you have an x squared, then you have to you'll have to factor at some stage, factor. But in order to factor, you got to bring it all over to one side of the equal sign. So these guys right here have to move over to the left-hand side. And that's what I'm showing you. See, subtract x, subtract 7, and then combine like terms. Let's see, 10 minus x, 10x minus x, and 25 subtract 7, 18. Looks good. And then if you factor this, and then you set each equal to 0. We did this in section, I believe it was in, well, I know it was in chapter 6. It's probably the last section in chapter 6 on the factoring that we had to do because it was solving, factoring and solving. All right, we get this. This is one of those ones that we end up having 2 possible answers. And we have to check to see if they work. So hopefully on the next page, I'm checking those to see if they work. Okay, I have checked them. Let's see what happens. I plug in -3 into the original. And be careful of this because I had to put parentheses around that. Plug in -3 and okay, that's 4. That's +3. Square root of 4 is 2. 2 plus 3 is 5. So check. That means this one's a good answer. Answer A-N-S-W-E-R. That means that's a good answer. Now we got to try the other possible solution. Plug in -6, which I did here, did there. That's a 1. Square root of 1 is 1. That's +6. 7, of course, doesn't equal 5. That's ridiculous. So you can't do that one. That's gone. So the only answer is the one I boxed up here. That's it. Okay, let's try another one. I want to bring that 3 over here because I want to square both sides with the radical by itself. So square root 3x plus 7 equals x plus 3. Okay, and then what you want to do is square both sides, leaving me 3x plus 7 equals, and don't forget to write this down twice. You got to write it down twice. The mistake is when you just take the power 2 and give it to the x and give it to the 3 without writing it down twice and foiling. We gotta foil. So I wrote it down twice. And then what I'm going to do is I'm going to foil. the right-hand side. So x squared and a 3x and a 3x and a 9. So far I think I did that foiling correct. Combine like terms on the right-hand side. Okay, now looks like I got a full factor because of the power of 2 against the factor, but you got to bring those two pieces to the right-hand side and set it equal to 0. So here we go. So I'm bringing this piece to the right and that piece to the right by subtracting 3x and subtracting 7 from both sides. Combining like terms, 6x subtract 3x, 9 subtract 7. Now I factor. Only choice for 2 is 1 and 2. Oh yeah, I'm going to get a 3 if they're both positive. I'm going to get a 3. So then you set x plus 1 equals 0 and x plus 2 is equal to 0. Why don't we just line that up right here? I was thinking about that as I was doing that. Let me just line those up so you can see. I'm taking this one and setting that equal to 0. And taking this one. So x equals -1, x equals -2. Those are my potential ones that I want to try. So I want to check. I'll check x equals -1 first. Here's the original. The original is right up here. Sorry. I need to make sure I check the original. Okay, here we go. Square root 3 times -1 plus 7. Subtract 3. I wonder if that's equal to -1. Square root. That's -3 plus 7. Subtract 3. I wonder if that's -1. Square root of 4. Subtract 3. I wonder if that's equal to -1. 2 subtract 3, yep, is in fact -1. So that means this is a good answer. That one is a good answer. Then you got to try the -2. So here's x equals -2. We're going to check that. So square root 3 times -2 and then plus 7. Subtract 3. I wonder if that's equal to -2. Okay, that's, what is that? That's -6. -6 plus 7 is square root of 1. Subtract 3 is equal to -2. I wonder if 1 subtract 3 is equal to -2, and it is. Well, then you have both of them working, and that's okay. I mean, you have 2 answers. Both of them are good. They're solutions. Both of them are good. All right, let's see what else I got left. Okay, now I'm looking at these. These are the hard ones. And I'm going to say, because of our circumstances, here being, oh my gosh, you know, the semester's changed so much because of this being sheltered in and the whole virus epidemic. I'm going to say the hard ones, that's what I'm calling these, you're not going to get on the exam. So just ignore this. When I say ignore it, if you come across anything that looks like this in your homework, don't do it. And I won't give you one on the exam. So don't do. 2 radicals in another term. Yeah, don't do. Don't do. Yeah, don't do. Don't do. don't do. Don't do. I'm sure you're thrilled about that one. Don't do the hard ones. And if you have questions or doubt about which problems those are and you're wondering, you can send me an email and I'll either confirm the problems or I'll tell you which problems personally, which ones not to do. Okay, until another time, and be safe and have a great day. All right, take care.